Okay, folks, let's go ahead and let's get started. We left off yesterday, and we left off yesterday with talking about how we can determine these molar masses for not only elements but for compounds as well. We said then that to get the molar mass of an element, we just go straight to the periodic table, find the mass number, and that mass number also indicates then the mass of 1 mole of that particular element. And so thus we call that the molar mass. So that's the molar mass for the element. Pretty straightforward. I'd suggested to you that if you're going to use the molar mass of the element, you can just go ahead and round off to the nearest whole number, so you don't have to worry about the decimal place. So that's how we get the molar mass of an element. Now, for compounds, then, what we have to do then is we just add up the molar masses of all the elements that make up that particular compound. And so, for example, with hydrogen, hydrogen is a diatomic element made up of two atoms of hydrogen. And so we take the molar mass of 1 atom of hydrogen, which is 1 gram per mole, and then we add it to another atom of hydrogen, which gives us then 2 grams per mole for the hydrogen molecule, which is H2. So essentially what we need to do then is to get the molar mass, we need to make sure we get the correct formula for the particular compound first. If we don't have the correct formula, then it's going to be very difficult to get the correct molar mass for that particular compound. So that's why I've been telling you since the beginning of this class back in August that you need to make sure you learn how to write out the formulas for these compounds. Okay? And so that's what we're going to do here. We're going to move forward. And I asked you to do this yesterday at the end of class. And so I'm just going to go ahead and go through this problem with you. Make sure you write down the answer here, and that way then you'll have it there to study. I will be making announcements on Monday about how we will go forward with quizzes and possibly exams. I know that I'd mentioned that I'm going to try not to give you exams, but moving forward, depending on how long we'll have to do this, I may have to adjust that and have you take an exam on the material that we've covered. Okay. But with that said, I hope that the videos so far have been informative for you. I'm still trying to work out an appropriate time in order to give you an opportunity to finish up the work here. And so the videos have been running about 20-25 minutes. I think that's a good working time for the videos. If not, like I said, I'll have to tweak that. Okay. All right. So let's go ahead then. Let's continue on and let's take a look at what we have here. And what I'd like to do then is take a look at the compounds we have. Okay, let's go ahead and let me start this up here. Okay. Sorry. Change color a little bit. Okay. So we have here carbon dioxide. Let's go ahead and start out with carbon dioxide. With carbon dioxide, then we have is 1 carbon and 2 oxygens. And so the molar mass of 1 carbon, remember, is 12 grams per mole. That's taken straight from the periodic table. This is the molar mass of 1 carbon atom. So that means that we have 1 here, and so we'll add that to 2 oxygen atoms. Okay, so 2 oxygen atoms. The molar mass of 1 oxygen atom from the periodic table, again, is 16 grams per mole. So we add that together, we get the total molar mass here then as being 44 grams per mole. And that then is the molar mass of carbon dioxide. Okay. Now make sure you understand, I'll just write up here for you. Make sure what that molar mass is telling us is this. It's telling us then that if we have 1 mole of carbon dioxide, and we're able to measure that and weigh that out on a triple beam balance or on a balance of some kind, it will give us a mass of 44 grams. I point this out to you because what we're going to go over next is that we're going to talk about how we can use this molar mass then as a conversion factor. So make sure then that you recognize what this molar mass means when we calculate for it. Okay. All right, let's go ahead and do the same thing for sulfur trioxide. We have 1 sulfur atom. The molar mass of sulfur, the element sulfur, is 32 grams per mole. Okay, we're going to add that to 3 oxygen atoms. So we're going to take 3 oxygen atoms. Each oxygen atom has a molar mass of 16 grams per mole. We add that together, and we get a molar mass for sulfur trioxide as being 80 grams per mole. So make sure you don't forget the units. Units for molar mass will always be grams over moles. Okay? All right, bromine then. This is a diatomic element. We have 2 bromine atoms that makes up this particular molecule here. Each bromine atom has a molar mass of 80 grams per mole. So therefore, the total molar mass for bromine as a molecule is 160 grams per mole. Okay. All right, hydrogen, we already did that. 2 hydrogen atoms. Each hydrogen atom has a molar mass of 1 gram per mole. So therefore, the molar mass for hydrogen then is 2 grams per mole. Okay. And then nitrogen, we have 2 nitrogen atoms. Each nitrogen atom has a molar mass of 14 grams per mole. So therefore, the total molar mass of this compound is 28 grams per mole. Okay. All right. So there we have it. Those are the molar masses of the compounds, okay, that we have here. Okay, so please make sure if you're not sure how we got this, if you're not quite sure how we got this, just make sure you email me, comment on Google Classroom, and ask your questions. I will have the after-school tutorial today at 3:15 to 4:15 on Zoom, on our Zoom Meet site. Okay, so make sure you get there and you ask your questions. Okay. All right. But moving forward, though, what we want to be able to do is we want to make sure that we can do some conversions that are going to help us with the chemistry that we'll have to do as we move forward. Okay, and the conversions here will be based. This diagram here will show us here. The conversions here is going to be based on what we know about the mole and the mole's relationship to representative particles, to mass, and to volume here. So what we want to be able to do is we want to be able to find then how we can convert from moles to particles and back. Okay, so that's one conversion that we will do based on the relationship that moles to representative particles. Okay? We want to be able to find then how we can convert between moles and mass, and that's going to be based upon the relationship between moles and mass here. And then finally with moles, and I'm going to switch out, please. Sorry, it's writing up on everything. Okay. Okay. And so we want to be able to define the relationship between moles and volume as well. Okay. All right. So what we're going to do then is we're going to talk about the all 3 of these conversions that we want to be able to do moving forward. Okay. Okay. So the third one here would be, sorry. Okay. And the third one here is our moles to volume conversion. Okay. All right. So like I said, we have then different relationships that we can use to help us to make the conversion factors we'll need to do these conversions. Okay. And understand this is just all basically dimensional analysis conversions using dimensional analysis. And so the 3 questions that we've been using since chapter 3, the 3 questions that you'll need to answer, what do you start out with, what do you end up with, and what conversion factors you'll need, you'll use that here as well. Okay. All right. So let's take a look at an example here of a problem that you will have to deal with in this section, and that is if you're given the moles of this particular compound. So we have sodium chloride, this is the compound here. If you're given the moles of this compound, are we able to find the mass equal to that? The reason why we want to be able to answer this question, folks, is because when we deal with compounds in a chemistry context, we can't measure out moles. There are no devices that we can use to measure out moles, but we do have balances. We do have triple beam balances, or we have scales that allow us to measure out masses. And so we want to be able to do this conversion here between moles and mass. Okay, so this conversion we have to do. So we have to ask ourselves 3 basic questions. That is, what do we have to start out with? Okay, so what is the starting unit here that they give us? So here they give us then moles of. So we start with moles of sodium chloride. So let's go ahead and write that down. Okay, so we're going to start out with 3 moles of sodium chloride. Okay, and we want to find then the conversion here is the mass. Okay, so they're asking us about mass here, the mass of sodium chloride, and that's what we want to solve for. Okay, Now, the question that we need to ask then is there a conversion factor that will allow us to carry out this conversion? And we just learned that one, and that is the molar mass, and that's what I told you. We need to make sure we can solve for that molar mass and understand what it means. Okay, so the molar mass, then remember, sodium chloride is just we add together, so the molar mass of sodium chloride. And let's go ahead and write this down here. Mass of sodium chloride then is 1 sodium atom, and the mass of 1 sodium atom is 23 grams per mole. Okay, and we're going to add that to the mass of 1 chlorine atom, which rounded to the nearest whole number is going to be 36 grams per mole. Okay, and so then the molar mass of sodium chloride then is going to be 59 grams, so 59 grams per mole. Okay, remember what this number means. It means then that for every 1 mole of sodium chloride, if we are able to get 1 mole of sodium chloride, that's going to measure out to be exactly 59 grams of sodium chloride. Okay, that's what this ratio means right here. So make sure you understand what this ratio means is it's 59 grams of sodium chloride. And I apologize for all the extra marks here, you guys. It's my writing tablet's giving me some issues. I'll work it out. That means that it's that's what that ratio means. That's what the molar mass is, 59 grams of sodium chloride for every 1 mole. So we can set up this equality here. Okay. And once we have that, remember, we can use that as a conversion factor. So we can plug it in up here in order to carry out our conversion between moles of sodium chloride and grams of sodium chloride. And so how do we plug it in? Well, we want grams of sodium chloride on top. So we have grams sodium chloride over 1 mole of sodium chloride. And why do we set it up that way? So that moles here will cancel out. So the moles of sodium chloride will cancel out. And here we have then grams of sodium chloride on the top and grams of sodium chloride on the top on the both sides of the arrow, which is a matter of plugging our numbers here, 59 times 3. And we get our answer then as being 177 grams of sodium chloride. And that is the answer that they want us to get. Okay. All right, so with that said then, this is a conversion. You want to make sure you ask the same basic 3 questions. What do you start out with? In this case then, we have moles of sodium chloride. What do you want to solve for? Grams of sodium chloride. The conversion factor here, if we want to do a moles to mass conversion, is going to be your molar mass. So remember, this here, what we described then as the molar mass of the compound. Okay, and so again, we had to calculate for this molar mass. Okay, let's go ahead then. I want you to try number 19 here. Take about a couple minutes to work out this problem. If nothing else, please try to set it up so that we can go over it. Just to set up the problem, and then when you get back, I'll work it out for you. Okay. Okay, let's take a look at this problem here. Let's go ahead and point out a few things here. Let's go ahead and highlight what we have. Okay. So if you notice here, they're asking you for the mass. So what you're asked to solve for is the mass, and it's going to be in grams. That means that what do you start out with? You start out with moles, specifically 1.72 moles of this compound, calcium chloride. Okay. Which means then as soon as you see that, you know then we'll have to use the molar mass to get this done. Whoops, sorry guys. Okay. Molar mass to get this done. So let's go ahead and let's calculate for this here. Okay. So what we start out with then is 1.72 moles of calcium chloride. What we want to solve for is going to be grams of calcium chloride. Okay. And so we need the molar mass of calcium chloride. So let's go ahead and calculate for that one really quickly. Okay. The molar mass of calcium chloride then, right here on the bottom, okay, is going to be 1 calcium atom, which is calcium has a molar mass of 40 grams per mole. Okay, we're going to add that to 2 chlorine atoms, which has a molar mass of 36 grams per mole. Okay, And then we end up with an answer that is going to be, 111 grams per mole. Okay, so that's the molar mass. Remember, what the molar mass tells us then is that we have then for every 1 mole, I'm sorry, let me write it up here. For every 1 mole of calcium chloride, that is going to be equivalent to 111 grams of calcium chloride. Okay, so we're going to take advantage of this relationship here in order to get this conversion in. So let's go ahead and plug it in. Okay, so we'll plug it in with 111 grams of calcium chloride on top and 1 mole of calcium chloride on the bottom. Why? That allows us to cancel out the units of calcium chloride. We plug in our answers, and we end up with an answer that is 112 here. Sorry, the answer it's going to be 112. I rounded off a little bit differently because 112 here and 12, and so we'll get our answer then as being 193 grams of calcium chloride. Good. All right. Be mindful here, sig figs count. We started out with 3 significant figures here in this number, and so our answer must have 3 significant figures. So be mindful of that. Okay. All right. So go ahead and make sure you write that down. And then what I'd like to do is to try one more problem here. Let's take a look at number 20 in your problem set. Go ahead and work that problem out, and then I'll get back together and we'll work it out together. Okay. So go ahead, take a couple minutes to work out this problem. Try to get an answer if you can. If not, like I said, at least set up the problem. Okay. Okay. Let's go ahead and let's take a look at what we have here. Let's mark what we have first. Okay, let's identify what we have and what we're going to be solving for. Okay, so here again, they're asking us to find the moles this time of this compound, aluminum oxide. This time they're asking us to find the moles, and they give us the mass. Okay, so we have, I apologize. It's so they're asking us to find the mass if we have the moles of aluminum oxide here. We have 9.45 moles of aluminum oxide. So let's go ahead and let's set up the problem there. If we start out with 9.45, go ahead and write this down. Start out with 9.45 moles of aluminum oxide. Al2O3, and we're going to be solving for the mass, grams, of aluminum oxide. Okay. All right, so let's go ahead and get the molar mass of aluminum oxide. So let's go ahead and write that down here. Aluminum oxide is then 2 aluminum atoms. Each aluminum atom has a molar mass of 27. Okay, so we have 27 grams per mole. Okay, we're going to add that to the molar mass of 3 oxygen atoms. Okay, so that's going to be 3 times 16 grams per mole, which gives us a molar mass then of 102 grams per mole. And remember what this means what this molar mass means I'll write it up here again for you, is that for every mole of aluminum oxide, it will have an equivalent mass of 102 grams. Okay, so that's what we have here, and we're going to take advantage of this equality here in order to get that done. Okay, so let's go ahead and plug it into our equation here. Okay, so we'll plug it in with 102 grams on top and 1 mole on the bottom. Why do we do that? That allows us to cancel out the moles of aluminum oxide here. And so we end up with grams of aluminum oxide on top and the bottom for both. We plug that in, we get our answer then as being 964 grams of aluminum oxide. Again, 3 significant figures here because we have 3 significant figures there. Okay. All right, very good. So what we need to be able to do also then. So make sure if you have any questions in this, comment on Google Classroom or email me. Okay, but let's continue on then. What happens then if we are asked to do the reverse? That is, then if we are asked to find the moles of a compound, if we're given the mass. Okay, well, we do the same thing but in reverse. Basically, then let's go ahead and set this up. This time we're starting out with 10 grams. Okay. Now, folks, unlike the other two problems that I gave you, this time I only give you the name. And so, like I said, you have to be able to get the correct formula in order to get the correct molar mass. So that is sodium sulfate right there. If you don't get the correct formula, it's going to be very difficult for you. I'm sorry, if you don't get the correct formula, you will get the wrong answer because the molar mass would be wrong. Okay, so here we're trying to find the moles of sodium sulfate. Okay, if we're given the mass here. So let's go ahead then and let's calculate for the molar mass of sodium sulfate first. Okay, so we have then Na2SO4. Okay, so again, if you don't have the right formula here, you're not going to be able to get the right molar mass. If you don't have the right molar mass, this calculation here will also be wrong. Okay, so we start out then with 2 sodium atoms. Each sodium atom has a molar mass of 23 grams per mole. Okay, we're going to add to that 1 sulfur atom, so 1 times the molar mass of the sulfur, which is going to be 32 grams per mole. Okay, and then to that we're going to add 4 oxygen atoms, which has a molar mass of 16 grams per mole. And so therefore, the molar mass of sodium sulfate then is going to be 142 grams per mole. Okay, which means then, I'm sorry, just to save ourselves, I'll write down here. For every 1 mole of sodium sulfate, that's going to be equivalent to 142 grams of sodium sulfate. Okay, so let's go ahead and plug that in. So the only difference here then is that instead of starting with moles on the left-hand side, we start out with grams. Instead of solving for grams mass, we're going to solve for moles here. So which means then we have to set up this conversion. We have to set up this equality so that this unit here cancels out, which means then we will put 1 mole this time on top, moles of sodium sulfate. And the mass then will be on the bottom, which means that we are dividing by the molar mass. Okay, 142 grams of sodium sulfate on the bottom, right? And that allows us to cancel out this unit here. So that cancels out. We have moles of sodium sulfate on both sides. Sorry, guys. Moles of sodium sulfate on both sides. We end up with an answer then that is 7.04 times 10 to the minus 2 moles of sodium sulfate. You can go ahead and write this out in scientific notation or expanded form if you want to, but you got to make sure you keep then in mind that you have 3 significant figures here because you have 3 significant figures here. Okay. All right. Let's go ahead then. I'd like you to try number 21 in your problem set, and we'll finish up with this. And tomorrow, Monday, we'll talk about the mole volume relationship. Okay, but let's go ahead and let's finish up with this problem here, and then we'll work on it. Okay. All right. Take about a couple minutes, set up the problem, and hope you can get an answer, and then we'll go over it. Okay. Let's go ahead and let's take a look at what we have here. Let's identify what we were given and what we're asked to solve for. In this problem then, we are given that we have 92.2 grams of iron 3 oxide. Okay, so that's what we were given. What we're solving for then is the moles of iron 3 oxide. That's what we were solving for. Okay, so let's go ahead and set up our problem. Sorry, folks. Let me go ahead and go back. Okay, so we have then, no. Well, let's see if I can get this out, sorry. That's what I get for trying the technical stuff, so I apologize, folks. Okay, all right, let's go ahead then. We start out then with 92.2 grams. Okay, we are given the formula here, folks. So we got to make sure we get the name here. So we got to make sure we get the right formula. So we have then iron 3 oxide. It's going to be Fe2O3. That's the formula that we're going to need. So then we start out with 92.2 grams of Fe2O3, and what we were solving for is the equivalent in moles of Fe2O3. So we'll need the molar mass. Again, folks, so we'll need the molar mass. Let's go ahead and find the molar mass of iron 3 oxide, which means then we have 2 iron atoms. Each iron atom has a mass of, here I have 56, yeah, 56 grams per mole. To that, we're going to add then 3 oxygens, which is 16 grams per mole. And so we get a molar mass here. I get a molar mass here of 160 grams per mole. And again, what that tells us then is that for every 1 mole of iron 3 oxide, that's going to be equal to 160 grams of iron 3 oxide. Okay, so that's the relationship that we'll be taking advantage of. So let's go ahead and plug that in up here to get our final answer. So if we start out with grams of iron 3 oxide here, we want to make sure we have grams on the bottom here. So let's go ahead and write that in. We have then 160 grams of iron 3 oxide for every 1, so that has to go on top, mole of iron 3 oxide. That allows us to cancel out that unit. Okay, and so let's go ahead then, and if you divide it, you'll get your answer then as being 5.76 times 10 to the minus 1 to the negative 1 moles of iron 3 oxide. Okay, and that'll be your final answer. 3 sig figs here, because we start out with 3 sig figs on the left over there. Okay. All right, so like I said, we will pick up with the moles to volume relationship on Monday. I apologize for the how messy the screens here look. I'm trying to work out. I'll figure out what's going on with my my pad here, my writing pad here, and then hopefully clean that up for Monday. Okay, so I'm going to assign a problem for you to do in just a moment. Make sure you get that done. Write it on your paper, and then submit it by the end of the period. Okay. I will see you folks then on Monday.